Okay, this is for my Calculus 1, and we're in our optimization chapter. And this is page 306, number 11, where we're talking about a box. So it says if 1200 centimeters squared or square centimeters of material to make a box with a square base and an open top, what is the largest volume? So this is our optimization, and we're looking, and when I say optimize, we're looking at maximum and minimum of things. And so if it says if 1200 square centimeters of material are used, so if you look at this, first of all, I want you to notice that I don't draw super well, but I hope you get the idea that it's a square base. So I just called it x times x because I know the sides are all the same. And I just labeled the height here as h. And this is my open top up here. So it's an open box. And I want you to think like of a tissue box, that if I'm talking about a material to make that box, and they're told this is what we have is 1200 square centimeters, that is my constraint. So if I'm talking about 1200 square centimeters of material, if you think about a tissue box, that's the cardboard, if you will, or the surface area of the box. Okay? The surface area or the cardboard to make the box. That's our constraint. Our objective is have the largest volume. So our objective is max volume. Okay, so this kind of organizes your thoughts. So the constraint tells us what we have to have, and they told us we had to have 1200 square centimeters. But first, I want you to use my picture to kind of come up with our own equation. So I look at it and say, okay, the bottom of my cardboard box is x squared. So my surface area is going to be the area of the base, which is x squared, plus, now I have four sides. I'm going to use yellow. That's one of the sides where it's x times h. And since they're all the same because the bases are all x, I have 1, 2, 3, 4 sides. So I'm going to say plus 4, the area of the sides, because there's 4 of them. That's my surface area. Now I know it's 1200, so in the surface area part, I'm going to change this to 1200. So I have x squared plus 4xh equals 1200. Okay, so far we have our constraint equation. Now I'm going to come over here for max volume, and I know the volume of a rectangular shape is length times width times height, or area of the base, which would be here, times the height. Either way, the area equation is going to be area of the base times the height. And it's not the area, it's the volume. Sorry about that. The volume of this is the area of the base times the height. All right, so we have our equations. So what I want you to do first is to solve for a variable. And I kind of want you to be smart about this, is if you look at this right here, I could solve for x. But then I'd have to take the square root. And it can be done, but the math is a little harder. So I actually just solved for h. So I subtracted x squared on both sides. So I have 4xh equals 1200 minus x squared. And then I'm going to divide everybody by 4x. So the height is going to be 1200 divided by 4x. And then we're going to reduce this down. Minus x squared divided by 4x. And when I do that, the height comes out to be 1200 divided by 4 is 300 over x minus, and then the x's, one will cancel. We'll just write it as 1/4 x. You could leave it as x over 4. That's fine. So that's my height. So now I'm going to take this. I have now my height in terms of my base x, and I'm going to plug the height right here in this spot because we're looking for max volume, but we have to put our constraint in there. When I do that, this is what I end up with. I have the volume equals x squared times 300 over x minus 1/4 x, okay? And then I'm going to actually distribute through here. So x squared times that, you end up the volume being 300 x, okay, minus, and I'm going to have 1/4 x cubed. There is the volume of the box in terms of x only. Now remember, in order for us to find the max volume, we have to find the x that has the max volume. Remember, we always did our first derivative and put it equal to 0. So we're going to come here, all right, and we're going to actually, I'll change colors here, do v prime. So v prime is going to be 300. It's just the power rule, minus 3/4 x squared, and then we're going to put that equal to 0. And that should tell us what x is going to give us the max volume. So let me go through and do this. So I'm going to move this over to this side. I have 3/4 x squared equals 300. I have x squared, and so you can either multiply by 4/3 or divide by 3/4, but either way, you're going to get x squared is going to be 400. And then we're going to take the square root and take the square root. Now, I'm going to say x is 20, and we're in centimeters here, so I'm going to say 20 centimeters. In all actuality, it's plus or minus the 400, but it's crazy to talk about -20 because we're talking about a size of a box. So we would reject it anyway. So we're just going to look for x is 20. Now, before I go any further, after I've done this, that I think I know what the max x is going to, the x is going to be for the max volume, I want you to come over here and do your first derivative test. So you're going to set up your v prime bar. Okay. We're going to put 20 centimeters right here, and we want to see, is it truly a max? So you're going to come here and look at this, or you can graph this. It doesn't matter. And I'm going to go to the left and to the right. So if you go to the left, say we put 10 in there, and you go put it in there, you're going to end up getting a positive number. If I come and put something greater than 20 in there, we'll try 30 or 40 even. When you do that, you're going to get a negative number. And if that makes you uncomfortable just plopping it in and doing it in your head, graph what's here in the yellow and just look on the either side of 20 to see what the value of your signs are. I see this is actually a max. This is my first derivative test. Yes, you have to do that. So now we're good. So I know x is 20 centimeters. Now I can come up and say here in the blue, what is my height? So my height is now going to be 300 over 20 minus 1/4 of 20. And when I do that, I get my height to come out to be 10 centimeters. Okay. So now I'm going to come up here and say, all right, so this is 20 centimeters here. So is this. And my height is 10 centimeters. Okay. Now I know the dimensions of the box, but they want to know the largest volume. So we actually have to go through and multiply 20 times 20 times 10, actually find the largest volume. So the max volume is going to be 20 times 20 times 10, or 20 squared times 10. It doesn't matter. And when you do, you get 4,000. And don't forget, it's in cubic centimeters because we're talking about volume, because this is centimeters, centimeters, and centimeters. So there is our max volume. So there's another optimization problem for you. So I hope that helps.